This is the 2026 Neco Chemistry Practical, the 2026 Neco Chemistry Practical on titration. The titration is between sulfuric acid and sodium hydroxide. So you're going to be carrying out titration experiments on tetraoxosulfate 6 acid and sodium hydroxide. Okay, so what we're going to do is to see how we can do this titration without even touching the apparatus. How we can go about this titration to get the perfect endpoint. The perfect endpoint. That's our target. Okay, now let's go. The first thing you need to know is to know how the balance equation will look like. Okay, so for this titration between sulfuric acid and sodium hydroxide, your balance equation is this. What you have, I'm showing here, is your balance equation. This is the balance equation. So these are the balance equation is going to be. Okay, so that is how your balance equation is going to be. Now for this balance equation, this is your acid. This is your acid. This is your base. So tetraoxosulfate 6 acid is your acid, while sodium hydroxide is the base. This is the base. And then this will be the product of the reaction. So it's going to give this salt and then the water. But we are not interested here. Our interest is on the acid and then on the base. Now, if you look at that, if you look at this balance equation, the number of moles of the acid, that is the number that is attached here, is actually 1. The number of moles of the acid, the number here is 1. So that's why you see number of moles of acid. Na means number of moles of acid is 1. And if you look at this, you can see that the number behind the sodium hydroxide is 2. So the number of moles of the base is 2. Nb means number of moles of base is 2. Okay, for this practical, you're going to be using 2.7 centimeter cube of sulfuric acid in 1 dm cube. So the acid you're going to be using will contain 2.7 centimeter cube of tetraoxosulfate 6 acid in 1 liter of water, 1 dm cube of water. So if we do that, the mass of 2.7 centimeter cube of sulfuric acid is actually this, is 4.968 grams. So I'm not going into details of how we calculated this because our intention is to do this practical and get the perfect endpoint. So this is the mass. And then for the practicals, all schools are actually using pipette that has a volume of 25 centimeter cube. So the pipette is where your base is going to be. Since the volume of the standard pipette that we use in our laboratories is 25 centimeter cube, so the volume of the base is already determined. VB here represents the volume of the base. So it is 25 centimeter cube. So that's what we are using for this calculation to get your perfect endpoint in this year's chemistry practical titration question. Okay, so we are going to apply a formula we know. This is the formula. Please take note of this formula. This is the formula that guides this experiment, this titration. Now, Ca means the concentration of acid, the molar concentration of acid, that is Ca. Va is the volume of acid. Va here is the volume of acid. Cb here means the molar concentration of the base, while Vb means the volume of the base. Na here means the number of acid, the number of moles of acid, and we got it as 1. We got it as 1. While our Mb here, this Mb here means the number of moles of base, and we got it as 2. From this equation, we are looking for the volume of acid because the volume of base is given. So if I make Va the subject of the formula, that is the volume of acid, I'm going to have this equation. So this is the final equation to use to calculate the volume of the acid to get a perfect endpoint. So the volume of acid is going to be number of moles of acid, Na, times Cb, which is the molar concentration of the base, times Vb, which is the volume of the base, all over Nb, which is the number of moles of the base, times Ca, which is the molar concentration of the acid. So please take note of this formula. If you have this formula, you are good to go. Now let's go to the next thing and see what we're going to do, how we can get the molar concentration of the base and also how we can get the molar concentration of the acid. So let's go. If we go like this is what we have. Let me show you how we can calculate the molar concentration of the acid and the molar concentration of the base. Now for us to find molar concentration, please don't forget, there is a formula we use. This is formula for molar concentration. The molar concentration of an acid, the molar concentration, the molar concentration of an acid is equal to the mass of that acid in grams divided by, this is the mass of the acid, divided by the molar mass. Mm here means the molar mass of the acid times the volume of that acid in dm cube, times the volume of that acid in dm cube. Okay, so if we do that, the mass of the acid given to us, the, okay, so the formula we use for molar concentration is this. This is the formula we use for molar concentration is this. The mass, sorry, the molar concentration, this is the formula for the molar concentration. It is the mass of the acid or the base divided by the molar mass of the acid or the base times the volume of the acid or base in dm cube. So this is the formula. So if I want to get the molar concentration of the acid, what I will do is the mass of the acid we got is 4.968. You saw it when we got the mass of the acid. So the molar mass of the sulfuric acid we are using is 98. Look at how you can calculate the molar mass here. So this is the way to calculate the molar mass. You do this, and if you do this, you're going to have 98. So I say 4.968 divided by 98 times, we are told that the acid will contain 4.968 grams in 1 dm cube. So the volume there is 1. That is 1 dm cube. The volume is 1. If we solve this, we're going to have this. So this thing we have here means that the concentration of the acid in mole per dm cube is 0.050. Please, this is the concentration of the acid you're using. The concentration of the acid you're using is this, 0.05069 mole per dm cube. So this is our Ca. Okay, so if we want to get the concentration, the molar concentration of the base, we still use this formula, we still use this formula, that the molar concentration is mass over molar mass times volume in dm cube. Now the base you're going to be using, Neco has asked the teachers to provide 4 grams of sodium hydroxide. So the sodium hydroxide we are going to use, the mass of it is 4 grams. So if I substitute in my formula, I'm going to have that Cb, which is molar concentration of the base, is going to be the mass of the base, which is 4 over molar mass of the base times volume, and the volume is here is 1 dm cube. So let's look at, this is the base, sodium hydroxide. This is how to get the molar mass of the base, please, and then that gives us 40 grams. So the molar mass of the base is 40 grams. If I go back to this equation here, I'm going to have 4 over 40 times 1, and that will give me 0.1 mole per dm cube. So the Cb of the base, that is the molar concentration of the base, is 0.1 mole per dm cube. Okay, so let's see the final thing we're going to do, how we can now substitute our values to get the final answer for the volume of the acid used. Okay, watch this. Watch this. Now, this is what I'm going to do. Remember, we have derived this formula already. We have derived this formula already that V, we have derived this formula already that VA is equal to NAVBCB over NBCA. I believe you know what NAVACBMBCA represents. So let's substitute the values. Na is the number of moles of the acid. And from our balance equation, the number of moles of acid is 1. And then Vb is the volume of the base. And the base is in a pipette. And we're using a standard pipette, which is 25 centimeter cube. So the volume of the base is 25. The molar concentration of the base, Cb, we got was 0.1. So if I substitute all these values here, of course, you know that the number of moles of the base is 2 we got from the balance equation, and then Ca, the concentration of the acid, we got it at 0.05069. So if we substitute these values and divide, the volume of the acid we are going to use is 24.7 cm cube. So this value you have here is your perfect theta value, your perfect endpoint. Your perfect endpoint for this Neco 2026 chemistry practical exam on titration is 24.7 centimeter cubes. So that is your perfect endpoint. 24.7 centimeter cube. Okay, so apply this and then you have your full mark, nothing, and this is the perfect. You have your full mark. Apply it and appreciate me later.